Okay, today we're going to talk about multi-step equations, but this is the second part of this lecture, and we're going to get into a little more complicated problems. Mostly they're going to involve the distributive property, and they're also going to involve combining like terms. So they really are multi-step, but we're adding this property of distributive and combining like terms. You solve these equations just like you would any other equations. You got to isolate the variable. Okay, so let's look at several examples of this. All right, in example 1, we're asked to solve 8x minus 12 equals 3x plus 7. We're going to solve for x. Now, all the equations in this lecture are the variable x, but you can use any variable, r, q. Okay, and this is similar to an example we did in the first lecture, the first part of this multi-step equations, but I just wanted to refresh your memory. So when I rewrite my equation, I got to be thinking get x on one side, because we see that x is on both sides. So as before, I'm going to look and move the smaller x term. That way I can most of the time keep my x term positive. So 3x's and 8x's, 3x's are smaller than 8, so I subtract 3x from each side, and I'm left with 5x minus 12 equals 7. So now this becomes a two-step equation. You have subtraction and multiplication, 2 steps now to complete the equation. I add 12 to both sides, and I'm left with 5x equals 19. Divide each side by 5, okay, and I get x is equivalent to 19 over 5, or x is approximately 3.8. Now, if you want to check to see if this is correct, you just plug 3.8 in for each of these x's and simplify, okay? So either answer is correct. In example 2, this is when we start to see equations involving the distributive property and combining like terms. So we're asked to solve the equation below for x in example 2. So here's our equation. I wrote it down here. 4x minus 2 times the quantity x plus 6. That's equal to 3 times the quantity 2x plus 7 plus 5. So I see the distributive property here, and I also see the distributive property here. And so the first thing I want to do is distribute that number in front. You want to be very careful here because this is minus 2. You could change that to plus negative 2 so you get the signs right. So I bring the 4x down, and I'm going to distribute now. Negative 2 times x is minus 2x. Okay, if you think about plus a negative. And minus 2 times 6 is minus 12. And that's going to be equal to, just distribute this 3 to both terms. 3 times 2x's is 6x's. And 3 times 7 is 21. And notice I wrote the like terms here in the same color. Okay, so we have integers here that are the same. We have x's here that are the same. So now that I distribute, I'm going to combine the like terms that I can if there are like terms. Okay, so 4x minus 2x is 2x. The 12 comes along for the ride. So you subtract 12 equals 6x comes along for the ride. And then we combine that 21 and 7. And that gives us 26. So now we're back to what we did in example 1. You have a equation with variables on both sides, and so we work with the smaller x's. You have 2 and 6 x's. So I subtract 2x from each side. Don't forget about that subtraction sign. That's got to come down. Okay, so it's minus 12 equals 4x plus 26. And again, now still two-step equation. Let's get x isolated here. In our third step, isolate that x. Don't forget that minus sign as we talked about. So subtracting 26 from each side gives me negative 38 here is equal to 4x. And so dividing each side by 4, you get negative 19 halves when you simplify negative 38 over 4. You can leave that as a fraction. You can write it as a decimal. Either answer is appropriate. All right, in example 3, we're going to continue on working solving equations. And again, here we have now the distributive property, but now I'm going to distribute on the left side both times. Okay? Now this is really tricky. That's not really tricky. You got to be careful of that subtraction sign. That's like multiplying by negative 1. Okay? So you want to be careful with that. So again, step 1, let's distribute. Okay? So we distribute the 2 in that first expression, 2x plus 2. And then basically what this is saying is you're taking the opposite of each term here. the opposite of the quantity x minus 2. So the opposite of x is negative x. The opposite of subtracting 2 is adding 2. Okay, so when you see just a minus there, you're really saying the opposite of this expression in parentheses. Opposite of positive x is, or adding x is subtracting x. The opposite of subtracting 2 is adding 2. And x plus 4 just drops down. Now, I used red here to see where my like terms were. Notice I have a 2x and a minus x, 2 and 2. So there's second step combined like terms. And so 2x minus x is x, 2 plus 2 is 4, and that equals x plus 4. So again, that x plus 4 is just coming along for the ride. Now, just subtract 4 from both sides, and you get something that there's no x anymore. Subtracting x, you get 4 equals 4. This is always a true statement. 4 will always equal itself. So because this is a true statement, there's no variable, it's just 0x. This is always true, therefore the solution will be all real numbers. When you get something that looks like this, remember, the solution is all real numbers. If you say, let's happen to say if this was a 2 and that was 4, 2 does not equal 4, you would know there'd be no solution to that equation. Okay, so what you're starting to see here is that we're distributing first, then combining like terms, and that's kind of what this process is. You're going to have to distribute and collect your like terms. So you're seeing a repeating process here. In example 4, we continue that process. We're going to solve for x here, and there's only one time where you have to distribute, and then all of a sudden you see this quadratic piece. But don't worry about that. Let's look at distributing first. We distribute the x through, we get x squared plus 3x plus 5 is equal to, and just leave that whole right side, x squared plus 7x minus 10. Okay? So now we look, we have a variable on both sides. X is on both sides, so we have to isolate x. There was no like terms here. We can't add x squared and 3x. They're different. Same thing here. So I actually first subtracted x squared off. So notice in this step down here, there's no x squareds. Okay, subtracted x squared from both sides. So now look, I'm back to equation 1. The first example I did, example 1, where I had just variables on both sides. 3x is smaller than 7x's, so work with that first. And we subtract 3x's from both sides, and we're left with 5 equals 4x minus 10. The variable is isolated, meaning it's on one side by itself. Add 10 to both sides, and divide each side by 4, and we're left with x is equal to 3.75. Our final example, example 5, again solving for x. Now this is a little bit different. This is a proportion. We have a fraction and a fraction. One fraction is equal to another, so cross multiply the proportion. So that's what I do. You see that in red here. So 5 times the quantity, x plus 7, that's equal to 2x times 4x. Okay, so don't forget that 5 has to be multiplied in both terms, not just the x. So now we distribute. So you have 5x plus 35, right? 5 times x, 5 times 7. That's equal to 8x because 4 times 2x is 8x. A two-step equation with variables on both sides. 5 is smaller than 8, so we're going to subtract 5x from both sides, which leaves us 3x, which is equal to 35. And dividing each side by 3, I get 35 over 3. Or I can put that as a decimal as about 11.67. Okay, so that's solving multi-step equations part 2, where we involve the distributive property and combining like terms. If you guys have any questions or comments, you can type them below, or you can email me at nicholas.bennett@dc.gov. We'll see you next time.